So before you guys left, we just quickly started talking about greatest common factor. We're just taking notes on greatest common factor. We broke down what that means. Greatest meaning the largest. Common meaning what?
Same.
Same. And then factors are just what are those numbers that are going to multiply together to get us to what we need to get to. So our big focus today is going to be on creating factor trees, like that video that we watched. So decompose a number into its prime factorization. Say that word. Prime factorization. So before I have you continue taking notes, I want you guys to put your pencils down and I just want you to watch and listen. Okay? All right. So on the test, you're going to see something. It's going to say, create a factor tree for 72. So what I'm going to do here, and this is just going to be my first example. We've got 5 or 6 we're going to work through, but I just want you to watch and listen to how I do this. All right? So create a factor tree for 72. What I want to ask myself is what numbers can I multiply together, or what factors can I decompose or break 72 into that are going to get me to 72? So give me one way I can break down 72.
7 and 10.
That's going to be 70. Genesis. 9 and 8. What's another way? Joshua. For 72. We got 9 times 8. What else can we do? I can do 8 times 9. Dylan.
So 3.
That's not going to get me to 72. I say this probably 5 times a day. You need to know your multiplication facts, guys, especially with today's topic. If you know your multiplication facts, this is going to be so much easier. Get them from the dollar store. Download a video game that's going to help you with your math facts. We all know you love that. Find a game. Practice your facts. What's another way? Sebastian.
9 times 8.
9 times 8. One more shot and then I'm going to tell you. Patrick.
6 and 12.
6 and 12. Okay. What I want you to understand with this is there are multiple ways that we can break down 72. But when we're doing this, we want to find what multiplies to 72. So we're just watching. And now what I'm going to do is I'm going to break down 9. What times what is 9?
3.
3 times 3. So watch the TV. This is what I'm going to do. 3 times 3. I'm just showing those factors that are going to get me to the number that I'm breaking down. When you get to a point that you cannot break numbers down anymore, like 3 and 3, those are called prime numbers. Why would 3 be prime? Why is 3 a prime number?
What?
Patrick.
3 to 3 is only 3 and 1. So
Yeah, that's a prime number. And prime numbers, you can only multiply 1 times that number. So at this point, what I'm going to do is I'm going to circle every time I see a prime number. Thank you guys for not having your pencils in your hands. I just want you watching. Okay, I still have to break down 8. How can I break down 8? What times what?
4 times 2.
Nicole? 4 times 2. Out of those 2 numbers, which one is prime? Look at the poster. Which one is prime? Daniel? 2. Every time I see a prime number, I circle it. I still have to break down 4. What times what?
That's it.
Brittany? 2 times 2. Good job. Okay. At this point, I have nothing left that I can break down. I branched off. I made my little factor tree and I branched off what I was able to break down. And when I can't take it any further, that's a prime number. I circle it. Okay. So then at this point, I'm going to get this prime factorization. There's that big fancy word. And this is one of the most important parts of this process. I'm going to write down every number I circled. I personally like to do it in order from smallest to biggest. Make sure you don't miss any. So I see a 2 times a 2 times a 2 times a 3 times a 3. Double check. I have 1, 2, 3, 4, 5 numbers circled. So I wrote down 1, 2, 3, 4, 5 of those. Notice the only thing I have left and what I wrote down in my prime factorization is prime numbers. Yeah.
But it, so no matter how you put it, it'll, like the numbers, it'll end up with 72.
Yes, and I'm glad you asked that because I was going to show you, no matter how I break down 72, as long as I do it correctly, I will always end up with 2 times 2 times 2 times 3 times 3. All right, so I did 9 times 8. What was the other way we said I could do it?
12 times 6.
12 times 6. So when we're working on this today, if I chose 9 times 8, you don't have to erase it. If you found another way to break down 72, you're still going to get that same answer. Are either of these prime?
Yeah.
Which one?
No.
Nope, because I can break them both down. Let's start with 12. How can I break down 12?
4 and 6.
4 and what? 3 and 2 and 6. It doesn't matter which one I choose. I'm going to do 4 and 3. Which ones should I circle?
Yes.
Brittany. 3. Why? Cassidy.
Look, take the prime.
Beautiful, because it's prime. I can't break that down anymore. I circle it. I'm going to go with 4. How do I break down 4? What times what, Teresa? Times 2. What can you tell me to do now? Ethan? What can I do now? Aaliyah?
So for the 2.
Yep. Because they're
Right.
prime. Am I done? No. Sebastian?
You now need to break down 6.
Yeah, I need to break down the 6. What times what? Everyone?
2 and 7.
2 and 3. You got to know your facts. What do I do now?
6 and 4.
Circle them both. They're prime. There's nothing else to break down. My next step would be to write that prime factorization. Again, I don't know why, but I like to write them in order from smallest to biggest. So I've got a 2, a 2, a 2. So I've got 3 of them. And I've got a 3 and a 3. That's the same thing I had when I did it 9 times 8. So again, this is me showing you that no matter how you break it down, you're always going to end up with the same prime factorization. And I want to show you as we go through this, if I were to check my work, I can do 2 times 2 times 2 times 3 times 3 and work it out. And I'm going to get back to 72. All right. If you do not have this written down, if you didn't get it written down before we left, oh yeah, I forgot. Let's get this copied down quick.
So, like,
So I'm writing what 2 numbers can you multiply together? That's important. It's multiplication. Alex, write this down. And I also wrote, there is more than one way. You need to continue breaking down the numbers until you only get prime numbers. That's your goal. So again, that poster up there is going to be your best friend for the next couple days. And as you keep doing this, you'll remember, oh yeah, 2 is prime, 3 is prime, 5 is prime. Oh yeah, 2 is prime. Once you get that prime number, circle it. That means you're done and you don't have to go any further. Once you're done with those, put your pencil down so I know I can move on. To see Daniel's done, his pencil's down. Josh is done. Sophia's done. Are you finished? Alejandro and Alexa are done. Give you about 40 seconds.
Yeah.
For those of you that are done, let's do another one. How can I break down 18? 18. Alejandro.
9 times.
9 times 2. What's another way? What's another way, Sophia? Boom, 6 times 3. I can do 1 times 18, but that's not really going to get me anywhere because I still have 18 that I'm going to have to break down. So you want to find those other factors that are going to get you to 18. So again, I'm going to show you that either way, you're going to get the same prime factorization, that same sentence with just prime numbers. Which one do I circle?
2.
2. How do I break down 9? 3 times 3. Circle them? Yep. That's all I got. So the prime factorization, I always start with my small one. 2 times 3 times 3. I talked about this with 72, but let me show you with a smaller number, 18. You know you wrote this correctly if you multiply it and you get back to 18. Let's try it. 2 times 3. 6 times 3. It got me back to 18. So I know I did this correctly if I get back to 18. Let's do this one. Which one do I circle? 3. Good. How do I break down 6?
Times 3.
2 times 3.
With a buzzer.
Circle. Good. Let me write it. 2 times 3 times 3. No matter how you break it up, you're gonna get the same prime factorization. Okay? Now, we're gonna see how this applies to the greatest common factor. Okay? Let's flip over. We're gonna go on the back side. We're gonna use this back side and we're gonna do some examples. So on a test, you'll see a question exactly like this. What is the GCF of 18 and 21? So here it doesn't just say, make a factor tree for 18, make a factor tree for 21. Now, just like yesterday with the least common multiple, they gave us two numbers, and we have to figure out what that greatest factor they have in common is.
You're coming off of the teacher.
You just did all the motions. Yes. Okay. In order to find the greatest common factor of two numbers, you make factor trees. So I'm going to make a factor tree for 18, and I'm going to make a factor tree for 21. For 18, I'm just going to do the 9 times 2 one. You could do something else.
Like this.
Yep, like the 6 times 3. But my biggest thing, make sure that you are circling your prime numbers. How do I break down 21?
Power and 7 times 3.
7 times 3. What can you tell me about both of those numbers?
We'll set them to the tiny.
They're prime numbers. I'm going to circle them both. The thing about this one, I cannot take it any further. That's as far as it can go. So my first step when I'm finding the GCF, make the factor trees. My second step, write out the prime factorization of each. So for 18, what is it? 2 times 3 times 3. I love that Genesis started with the 2. I like to start small and put them in order, and you'll see why. Then right underneath it, I list 21. And that was 3 times 7. All I did so far was make those factor trees and write out the prime factorization. To find the greatest common factor, the GCF, I have to figure out what do they have in common. In my list I made, what do they both have?
3.
A 3. They have a 3. I'm going to circle that. Do they have anything else in common? Nope, not in this one.
Energy.
Yep. So my greatest common factor of 18 and 21 is the fact that they both share a 3. So my GCF is 3, and that's it. If you can do a factor tree and find what they have in common, that gives you the GCF.
Wait.
We're going to look at a bunch of different examples of the different types that you're going to see and what to do for each. So my second example, we're going to find the greatest common factor of 30 and 45. All right, what was my first step? What did I do in that first problem? Okay, so write down 30 and 45, and what do I do with them?
Write that 2 and modify them.
I need to create what?
The factor them.
The factor trees. How can I break down 30?
3 times 2.
I could do 3 times 10. What else?
Only 2.
Ooh, 15 times 2. 5 times 6. I think that's it. Let's do 5 times 6. You could do something else. The next one I'll let you guys try. Which one do I circle? 5. Like I said, you'll just remember after a while, hey, 2 is prime, 3 is prime, 5 is prime. Numbers that we can't break down anymore. And then 6, I'm going to do 3 times 2. They are both prime. Circle them, circle them. And that's all I can do. What about 45? How can I break down 45?
So 5 is times.
Yeah, 5 times 9. Patrick, you got the 15. What's 15 times what?
15 times 4.
Not 4. 3. 15, 30, 45. But let's do 9 times 5. Which one do I circle? 5. How do I break down 9? 3 times 3. Good job. And I circled those because they're prime. I'll let you get that copy down. What's my next step?
Is all about to multiply that to multiply to see like the cost of the ones that are common.
Yes. See the ones that are in common. So we're going to write out, what's that fancy word?
That thought
Prime factorization. Good job. All right. So I like to do it where I'm going to write 30. And then I'm going to write them in order. So what should I put first?
2 to
2 times 3 times 5. I'm going to do the same with 45 right underneath it. 45 is 3 times 3 times 5. This one's a little different. Why?
because of the fourth one.
It has more than one number in common. What's the first one they have in common? 3. Booyah. What else? 5. Good job. Notice I'm circling them in pairs. So I have a pair of 3s and I have a pair of 5s. Sebastian?
We are trying to find which one is the greatest.
So this one's a little bit different. That's a good guess. You would want to think the greatest common factor would be, hey, which one's the greatest? However, in this situation, when you have more than one number that they have in common, like the first one, they just had a 3. So the greatest common factor was 3. When they have more than one in common, we multiply what they have in common together. Okay? So in this situation, the greatest common factor would be 3 times 5. So what is the greatest common factor? What is it?
15.
15. Really quickly, I'll show you why. Sebastian, I like that you said, well, shouldn't we be looking for the greatest number? And you would think it's 5. There's another way that you can do the greatest common factor, but I've just learned over the years that I like to think of greatest common factor, I hear factor tree. Because on the test, if I say, hey, what's the least common multiple of 9 and 15? And then the next question says, hey, what's the greatest common factor of 9 and 15? I want your brains to have a way to remember, hey, when I see least common multiple, I'm going to multiply forever and ever and ever. When I hear greatest common factor, I'm going to do a factor tree. I try to separate the two of them because it gets really easy to mix them up. So back to what Sebastian was saying. When I first started teaching, I was like, okay, well, we can list all the factors and kind of do it the same way we did for LCM. What are the factors of 9? What times what gets me to 9? Actually, hold on, let me do 30 and 45. What times what is 30?
4 times 5 times that by secret.
Okay, I'm gonna start with 1 times 30. I heard, what about 2? 2 times what? 15. 3 times?
4 is 10 or 6.
3 times 10. 4 times nothing. 5 times 6. And that's it. Okay. The problem with this method is when you get to bigger numbers, it's really hard to make sure that you get every single one. So I just don't care for this method. But I'm going to show you where Sebastian was like, well, why isn't it 5? Okay, how can I break down 45? I can do 1 times 45. Is this divisible by 2? Think back to our divisibility rules. No, because it needs to end in a what?
0, 2, 4, 6, or 5, or 6, or 8.
Slow down. This is not divisible by 2 because it needs to end in a 0, 2, 4, 6, or 8. This is where our divisibility rules come back in. Anyway, 45 divided by 2 doesn't work out. What about 3? 3 times 15. Good. 4 times nothing. 5 times what? 9. 6 times nothing. 7 times nothing. That's all it is. And again, when you get to bigger numbers, you might miss them. Especially because we're only really good with our 12s, up to our 12s, right? Except Patrick and his 15s. Now, if I did it this way, the factors are 1, 2, 3, 5, 6, 10, and 30. For 45, it would be 1, 3, 5, 9, 15, 45. Oh, I missed one here. 10, 15, 30. Okay, we can do it this way. What do they have in common?
10.
Nope.
5, 50.
They have a 3.
There's a 5.
They have a 5. They have a 1. 15. Okay. What is the greatest factor they have in common? 15. This is where 15 comes from. You can do this way, but again, I just want to try to teach you guys a way. Greatest common factor tree, least common multiply forever. I want you to kind of separate the two because we kind of do this with LCM. So I don't want to do the same sort of kind of method with the greatest common factor. I want us to do the factor trees. However, this is the behind the scenes of where the 15 comes from. Okay. So the greatest common factor in our example is not 5, it's actually 15. That's why we find those pairs. So they had a 3 in common, they had a 5 in common, and we multiply them together, and that's where 15 came from. Okay? All right, let's do another example, and I'm going to have you guys make the factor trees. So we're going to do the greatest common factor of 42 and 70. So I want you to give that one a try. Step 1, write down your factor trees.
Sorry.
Yeah,
Right?
not today. No, today we're just going to do a couple more examples, and then I want us to really practice our factor trees. So then tomorrow, I will let you do partners tomorrow, and we'll do GCF.
What's that?
GCF. Greatest common factor. So one more time, you guys are doing the factor trees for 42 and 70. Factor trees for 42 and 70. Somebody's out. Ooh, 21 and 2.
70.
Do you need a pencil? Go get a pencil.
It's good. I'm saying you're right.
Make your factor trace.
There's
I'm going to get some of us started. What times what is 42?
60 seconds.
6 times 7. I also saw a few people do 2 and 21. That works too. 2 times 21 is 42. Six times 7. There you go. So start with 42 and you want to do your branches. Is 7 prime? Can I break 7 down anymore?
Cool.
What times what?
Then
I'm something.
screen. Took
So just 2 numbers. So you said 1 times 7, but that didn't really get me anywhere. So is 7 prime? Look at my list. Kind of can't see because of the glare, but is 7 prime? Is it? 7 is prime. I can't break it down anymore. Says yours or hers? Yours. So 7 is prime, so you're going to circle it.
Come.
Okay. A couple things I want to address as I walked around, and I want to catch this now before we get way too into it and keep making the same mistake. So, 42. I can do 7 times 6. So right now we're watching the TV because I'm going to go over 7 times 6, or I'm going to go over the factor tree for 42. 7 times 6. Which one of those is prime?
7.
7. Because the only other way, and I'll use pencil quick, the only other way that I can break this down is 1 times 7, and that got me nowhere. So if I can't break it down anymore using multiplication, I circle it.
that's good.
How do I break down 6?
So it's 15 times 3.
2 times 3. They're both prime. I circle them. That's all I can do with 42. Who had 7, 2, and 3 circled? 7, 2, and 3. Okay. So 42, I didn't really see many errors. I thought it was funny that some of you did 21 times 2. That's not where my brain went, but that works. How can I break down 70?
35. 7.
35 times 2, yeah.
7 times 10. And yeah, it's
Yeah, 7 times 10. That's what most of us are going to say is 7 times 10. Okay.
Good. Here.
Which one do I circle? 7. Okay, really quick, watch the TV. This is what I saw, and I want you to show me where they went wrong.
that's like pretty good. Yeah, I know. They added. Try plus.
I see this a lot. Okay. You cannot, it's not addition. When you're thinking about prime factorization, it's multiplication. When we are factoring the number 70, we're just looking for multiplication. This person said 5 plus 5 is 10, which you're not wrong, but this is multiplication. So one of them is 5. What does the other one have to be? 2. Do not make this mistake. It is not addition. I forgot about that. I see this a lot. So that 10 is going to be 5 and 2. Okay. Those are prime. I circle them. I can't break it down anymore. What's my next step? What is the fancy word? I need to get there. Prime factorization. Mom and dad say, what'd you learn today? Prime factorization. 42. I write them in order. So I start with 2 times 3 times 7.
Can got
And then I'm going to list 70. So I've got 2 times 5 times 7.
the part. 7.
What do they have in common?
2 and 10, 11 and 10.
A 2 and a 2 and a 7 and a 7.
Spoon.
So they have more than one number in common. So don't shout it out. I want you to think for a second and give everyone else a chance to think. Don't shout it out. What is the GCF going to be? Alex, did you have a question?
The pros,
You're going to tell me?
like the pros, numbers are like 3 or 5, right?
What about them?
Because they are all fine of these.
Yeah. So Alex said every single number down here is a prime number. Exactly. That's what those factor trees are doing, is it's breaking those numbers down. It's decomposing those numbers. So we're only left with prime numbers. Guys, this is definitely going to be something that you see in 7th grade, in 8th grade, in high school. Being able to factor or break down a problem, taking out their multiplication parts. So when I first talked to you guys yesterday about the learning target, those vocabulary words that I have underlined, you will see these not only in 6th grade, you will see them in high school, you will see them in 7th and 8th grade. By the end of the week, you need to apply the relationship between factors and multiples. So you need to know the difference. And then we're going to get into the distributive property. But the takeaway, which Alex noticed, is, hey, these are all prime numbers. Right, your factors, we ended up with just prime numbers, and that's our goal. So that's a good observation. Okay, tell your shoulder partner, what did you get for the greatest common factor?
Oh, you.
Well, don't put all on. Go see. And I go to the point. And got the biggest kind of.
Oh, boys.
So show point. I mean, Jackie. Listen. Fell born back. But that's about it.
Okay. What did we get?
14.
Did anybody get anything different?
You know, I did that.
Okay, it's 14. It's 14. When you have more than one set of numbers circled, you multiply them together. So the greatest common factor I'm going to write is 2 times 7, which is 14.
This is more than so.
Ooh, that is such a good question. That's going to be our next one.
Huh? Hey, a new thing.
Yes, new page. I'm going to do one more example, and then I'm going to send you guys off. I want to show you one more example. Okay? We're on a new page. Some of you maybe. But I'm going to keep on going with that. I'm on number 4. Greatest common factor of 48 and 56.
Yeah, you.
Step 1. Factor trees.
Right? So,
Yeah. Good job.
If you want to give this a shot on your own,
yeah. Yes. Yeah.
cool beans. I love the positivity.
It's good. It is.
You're never going to get better if you don't try these on your own. Sitting and waiting for the answer isn't going to get you far.
But as they have played, deep and like weird, bitter, which you have to play. Well, bad. I'm sure. Well, then, Ernst.
I see somebody broke 48 into 8 and 6. Did somebody do something different? Ooh. Somebody did 2 and 24.
Do you think that
Watch it.
Anybody do 12